Now we want to put together all of the things that we have been working on this week as far as graphing is concerned. Now that we know how to do the transformations, we know about the vertical and horizontal asymptotes. We know how to find the vertical and horizontal asymptotes. We know what to do if it has holes or if it has a slanted asymptote instead of a horizontal asymptote. And we just want to practice putting it all together and actually getting the entire graph. So we're going to look at a couple of examples. So we're going to start with y equals 1 over x squared minus 4. So when I look at this rational function, again, factor first. We always want to factor. When I'm looking at it too, I notice it's a proper fraction. The bottom is larger than the top degree, so it is a proper fraction. So I know I'm going to have a horizontal asymptote at y equals 0. So I know that horizontal asymptote is going to be right here. So I've got my horizontal asymptote marked. When I factor, this is a perfect square minus a perfect square. So it's going to factor to be x plus 2 and x minus 2, which means that I have a vertical asymptote at x equals negative 2 and x equals positive 2. So at negative 2, I've got a vertical asymptote. And at positive 2, I have a vertical asymptote. And now I just need to figure out where the branches of this graph goes. In general, we are looking for there to be parts in each section, but you can never have parts on top of each other. Remember, that wouldn't pass a vertical line test. It wouldn't be a function. We can just go up into something like Desmos and kind of get a hint and say, hey, tell me where those are. That's not a problem. X squared minus 4. If you don't have something like Desmos handy, then you can just pick points. Pick a number like negative 5 that's way over here past the asymptote, and it'll give you that point. And then you know, oh, it's up in this top side. All right. And then this one's over here. Notice our graph hugs those asymptotes. Doesn't quite get on them, but it hugs them all the way down. And so that means we have that for our graph. Again, when we are grading, assessing these kind of things, and especially when you're having to hand draw them, you can't really hand draw this well without the asymptotes there. They're your guidelines. You could notice by the way I had that on there, they hug those asymptotes and they just kind of nestle down in these corners. And so it is really important for you to put those asymptotes on there because they're your guidelines. They're what keep you, coloring inside the lines, so to speak. So you want to always put your asymptotes on there. Just remember they're dashed lines because they are not actually part of the graph. So let's look at a different example. So our next example is going to be y equals x squared minus x minus 2 all over x minus 2. All right. So when I look at this, I notice that this polynomial is going to factor. Two numbers that multiply to equal negative 2 and add to equal negative 1 is negative 2 and positive 1. So when I factor this, that gives me a common factor. This is going to simplify. My x minus 2's are going to cancel out. And that means I'm going to have a hole. All right. And in fact, my hole is going to be at 2 because I can't let x minus 2 equal 0. I can't, if it's 0, it doesn't cancel out. It doesn't work. So now I want to look at what's left over. The graph that's left over is just y equals x plus 1. Well, that's great news because that's linear. It's not even a rational function anymore. That makes it a lot easier to graph. When I plug 2 in, 2 plus 1 is 3. So that means my hole should be at the point 2, 3. So I'm going to go ahead 2, 2, 3, and I'm going to put a little hole there. And then I want to graph my line. Well, this has got a y-intercept of 1 and a slope of 1. So that's just going to go like this. And it's just got a hole in it. And so that's what it would look like if we did it on Desmos 2, just to check and make sure that we're not making this stuff up. X squared minus x minus 2 divided by x minus 2. And there you go. My line got a little off down here. My drawing was not that great, but I do want to point out that up here at 2, there it is, undefined, is the little hole. So it did have a hole there. So you always want to watch out for holes. Another example, let's look at one more example of putting all of this stuff together. So we have y equals x squared plus 3x minus 5 all over x minus 5. So two numbers that'll multiply to equal -5 and add to equal 3, there's not one. The only numbers that multiply to equal -5 are 5 and -1 and -5 and +1, and neither one of those add to equal 3. So this is as good as that's going to get. Nothing simplifies. I have no holes. I do have a vertical asymptote. So I've got a vertical asymptote at x equals 5. So I can go ahead and put in my vertical asymptote. And then I look at my rational function and realize it is an improper fraction. The degree on the top is bigger than the degree on the bottom. So it's an improper fraction, which means that I need to find the slant asymptote. And to find the slant asymptote, I'm going to have to do a little bit of division. So x squared plus 3x minus 5 and divided by x minus 5. So that's going to be x. I get x minus 5x, so that's x squared, excuse me. And then when I subtract, minus a negative is plus a positive, so then this was going to be 8x minus 5. And then that's just going to be 8. And 8x and -40, and subtract minus a negative. And then this is just going to be the remainder, but we're not interested in the remainder. Remember, just the quotient up here without the remainder, the whole number, is what we're interested in. So this means that we're going to have a slant asymptote at y equals x plus 8. All right, so that means I have a y-intercept of 8. It's got a slope of 1, so we're just going to get our little slant asymptote up here. And now we just want to figure out where is, oh, I think I got off a little bit. There we go. Okay, so where is our graph going to fit in between these asymptotes? So if we go up and look at the graph itself, y equals x squared plus 3x minus 5 divided by x minus 5. We can see, oh, here is where the graph fits nice and snug. We've got a couple of x-intercepts. We've got a y-intercept. And that helps us, give us some good actual points to put on our graph when we're graphing it. I'm assuming there is a branch that's up here in this part, because if it was here, that wouldn't pass a vertical line test. So I'm going to zoom out a little bit. Yeah. So there it is. It was just hiding up here where I couldn't see it. So it does have a second half, but it followed that vertical asymptote and that slanted asymptote.